Welcome back to Jobs and Education YouTube channel. In this video, we are going to see some previous year physics questions for Ecet. So the first question reads: if mu s, mu k, mu r are coefficients of static friction, sliding friction and rolling friction, then mu s is static friction, mu k is sliding friction, mu r is rolling friction. Then arrange in the ascending or descending order. So the option 1 is rolling friction is less than sliding friction less than static friction. Second option, sliding friction less than rolling friction less than static friction. Third option, sliding friction less than static friction less than rolling friction. Fourth option, sliding, static and rolling frictions are equal. So the option 1 is correct. Rolling friction is less than sliding friction less than static friction. Remember this answer. The second question reads: a body falling from a height of 10 meters. A body falling from a height of 10 meters rebounds from a hard floor. A body falling from a height of 10 meters height is rebounded from a hard floor. If it loses 20% of its energy in impact, it will rise. Option A 10 meters, option 2 8 meters, option 3 5 meters, option 4 12 meters. Here initial potential energy equals to mgh, where h is the 10 meters. It loses 20% of its energy, that is equals to 0.2 mgh. Its kinetic energy after rebound is 0.8 mgh, which is nothing but half mv square. Now the ball will rise to a new height of h, and equating this kinetic energy half mv square, that is equals to mgh. So this 0.8 mgh is half mv square and mgh is half mv square. Equating this 1 and 2 equations, 0.8 mgh equals to mgh dash. H dash is the new height. So h dash equals to, by equating these two equations, h dash equals 0.8 h. He given h is 10 meters. So 0.8 into 10, 8 meters. So here the first one is half mv square, kinetic energy is equals to 0.8 mgh, and after rebound the new height will be h, so kinetic energy equals to mgh dash. Equating these two kinetic energies, we will get the h value, 0.8 into 10, 10 meters. Option 2 is correct. Now let's see the next question. A body of mass 10 kg is traveling with uniform speed of 5 meter per second. He given velocity equals to 5 meter per second and m equals to 10 kgs. He is asking kinetic energy. We know the kinetic energy equals to half m v square. He given mass as 10 kg and velocity as 5 meter per second. So by substituting mass and velocity, we will get the answer nothing but 125 joules. For kinetic energy, the formula is half mv square and the units of kinetic energy are joules. Remember this. Here the question reads: if a stone is thrown up vertically, if a boy is playing with a stone and he thrown the stone upward vertically and it returns to the ground. After throwing it upward, it returns to the ground. Its potential energy is maximum at, means mgh will be maximum at. If h is more, the potential energy mgh will be more. So at maximum height, at maximum up to which it can travel, it will be the potential energy will be the maximum at that height. So the answer will be at the maximum height. So remember this, h should be maximum, means at maximum height the potential energy will be maximum. Next question. A seconds pendulum. A seconds pendulum is taken from earth to moon. This is earth, this is moon. It is taken from earth to moon. If it is to act as a seconds pendulum there also, when it is taken from earth to moon, it should also act as seconds pendulum on the moon. The length of the pendulum. So if it taken from earth to moon, the second pendulum should act as same as second pendulum only, but the length should be, it should be increased or decreased, need not to be changed or difficult to imagine. It should be decreased. The length of the second pendulum should be decreased. Then only it acts as second pendulum and works on the moon. The length of the second pendulum should be decreased on the moon. Here the next question. In a simple harmonic motion SHM, in a simple harmonic motion, the maximum acceleration and maximum velocity are 31.4 meter per second square and maximum velocity is 10 meter per second. The time period is, he given acceleration and velocity, maximum acceleration and maximum velocity. He is asking for time period. Option A 4s, option B 3s, option C 2s, option D 0.5s. He is asking for time period. We should calculate the time period. So here maximum speed Vm, that is equals to omega into A. Maximum acceleration Am, that is equals to omega square A. Okay, now acceleration by speed, that is nothing but omega square A by omega A. A cancel, omega cancel, therefore the answer will be omega. Omega is nothing but 2 pi by t. So or this acceleration is 31.4 and speed is 10. He given the values. Now 2 into 3.14 by t. Omega equals to 2 pi by t. So 2 into 3.14 by t. Now t equals to 2 seconds. By equating this, we will get t equals to 2 seconds. Option C is correct, 2 seconds. He given that two tuning forks of frequencies 256. Frequency F1 equals to 256 and F2 equals to 258 vibrations per second. Means units of frequency, vibrations per seconds, are sounded together. They both sounded together. Then the time interval between two consecutive maximum heard by observer. By observer, two consecutive maximum heard. When he hear the two consecutive maxima, what is the time interval between them? He is asking. Option A 2s, option B 0.5s, option C 250s, option D 252s. Now let's see the answer. Frequency 1 256, frequency 2 258. Both tuning forks are making beats, so we know that T for maximum time period, that is equals to formula 1 by n2 minus n1 seconds, means 1 by frequency of second tuning fork minus frequency of first tuning fork. Okay, now 1 by 258 minus 256, the answer will be 0.5 seconds. The answer will be 0.5 seconds. Option 2 is correct. 1 by n2 minus n1 seconds time period equals to. According to Hooke's law, the relation between stress and strain, we know that stress is always directly proportional to strain. Option A is correct. Stress is not inversely proportional, not directly proportional to strain square, and not directly proportional to under root strain. Stress is always directly proportional to the strain. If stress increases, strain increases. If stress decreases, strain decreases. An iron needle slowly placed on surface of water floats on it because, suppose there is a water and it's the water surface, a iron needle is placed, so it floats on water surface because of its elasticity, of viscosity, of surface tension, of its shape. Elasticity no, viscosity no, and due to its shape also no. It does not depend on shape, it only depends on its surface tension. The water surface has some surface tension, so this iron needle floats on surface of the water due to its surface tension. What happens to the force between magnetic poles when their pole strength and the distance between them are both doubled? Suppose if you take a bar magnet N as North Pole, South Pole, when their pole strengths and the distance between them, if this distance is doubled and pole strengths also doubled, then what happens? Force increased by 2 times, force remains unchanged, force become halved, force increased by 4 times. Force remains unchanged. If the distance doubled and also the magnetic pole strength at the poles doubled, there will be no change in force at these two poles. So doubled or tripled or anything also, there will be no force changed. Next question. Substance which when placed in a magnetic field acquire favorable magnetization in a direction opposite to that of the applied field are called. When a substance placed in a magnetic field, suppose this is a magnetic field and here a substance is placed, it acquires magnetization, means the magnetic it also acts as magnet in a direction opposite to that of the applied field are called diamagnetic substance, paramagnetic substance, ferromagnetic substance, ferrimagnetic substance. The answer is diamagnetic substance. A substance placed in a magnetic field acquires magnetization in the direction opposite to the applied field. If the field is in direction and the magnetization will be in opposite direction, if such incidence takes place, then the substance called as diamagnetic substance. Option A is correct. The resistance of wire of length L and diameter D is R ohms. Length L, diameter D, the resistance will be R ohms. The resistance of another wire of same material, wire A and wire B having same material and length L but diameter is halved, then what about the resistance he is asking. If same length and the diameter is halved, then the resistance will always doubled. Then the resistance will always multiplied with 4R. If the diameter is halved, length is same and also material is same, then the resistance will be increased 4 times. If it is halved, the resistance will be increased 4 times. So option C is correct, 4R. To balance the bridge in the circuit, the value of R should be, he given a circuit, see this is 15 ohms, 5 ohms, R ohms, 12 ohms, 60 ohms, and these all are 5 resistance connected in a circuit, and he is asking the value of R to balance the bridge. To balance this bridge, he is asking to find the value of R. Option A 8 ohms, option B 4 ohms, option C 20 ohms, option D 12 ohms. Let's see the answer. Given R1 equals to 5 ohms, R2 equals to R plus 12 ohms, R3 equals to 15 ohms, R4 equals to 60 ohms. So at the balance condition, R1 R4 equals to R2 R3. Let's see. R1 R2 equals to R3, R1 R4 equals to R2 R3. So we know the R1 is 5 into R4 is 60, R2 is R plus 12. This already given 2 and it is added with R plus 12 into R3 value is 15. So 5 into 4 plus R plus 12. So now this 5 4s are 20, that is equals to R plus 12. R equals to 20 minus 12, which is nothing but 8 ohms. Here we should find the R1, which is R1, which is R2, which is R3, which is R4 in given resistance. So then R1 R4 equals to R2 R3, equating product of R1 R4 is equals to product of R2 R3. By equating these two equations, R1 R4 and R2 R3, we will get the R value. In R2, the resistance is R plus 12 ohms. From this R2, there we will get the R as answer 8 ohms. Here the option A is correct, 8 ohms. Thank you.